and welcome back. We're on lesson 4. We're looking at the Pythagorean theorem, and I have this nice little stick. It's about 10 centimeters long. I lean it up against the wall, and it's about 5 centimeters away from the wall. Now, how high is it on the wall? I'm going to guess it's about 8 centimeters. Okay, so now if I'm going to measure that, my guess was 8 centimeters, and it is approximately 8.5 centimeters long. Okay, I used the little ruler on my slides to measure it, so it's not exactly right, but it's close. Okay, so I have a 10 centimeter long stick. I lean it against the wall and put it 5 centimeters away, and it's measuring about 8 centimeters. Okay, now I pull the bottom out about 10 centimeters away from the wall, or 8 centimeters away from the wall, sorry. And I want to know now what that height is here. And I'm going to take a guess, so like it's about 5.5 centimeters long. And then when I actually measure it, it is about 5.5 centimeters long. Okay, so what do I want to do with this information? Obviously, I can't do this one because this is my little stick. All right, this is going to help me. If there was one of these sides that I didn't know the answer to, I could fill this in. So I want to know what the relationship is between the length of the stick and the base here and the height. So I'm going to fill this in. The base was 5, and I'm going to do the squared there, and the height is about 8.5. And then if I multiply, or if I do this square of 5 and the square of the height, and I add them together, how much is that? So that would be 25 plus, and then I do not know 8.5 multiplied by itself off by heart, and that is 7.25. And then if I add these together, I'm at 97.25. Okay, I just want you to hold that in your head for now. That's this first one here. So I have 5 squared plus 8.5 squared. This is 25. This is going to be 72.25, and this is equal to 97.25. Okay, just making it a little neater for you. Easier to see, because we're trying to draw a connection here. All right, now I'm going to do this one here. So I have the base is 8 squared. This is about 5.5 centimeters squared. This would be centimeters squared, right? And then this is going to end up being 8 squared plus 5.5 squared. Now I have put it into, I'm actually going to do it, the calculation here. And this is going to be 8 squared, I know is 64, plus, and 5.5 times 5.5, that's going to be 30.25. These are centimeters squared. Okay, and then I'm going to add these together, and that is 94.25. Now, if I were to square the length, I would get 100 centimeters squared. Okay, now these were approximate, okay? Not exact. I don't have a proper stick, I don't have a wall, I don't have anything to really measure it out on. So I'm pretty darn close for not being measuring completely accurate to the length of the stick squared. Now, one of the stories that I have for you here is when the Egyptians were building the pyramids, they discovered a formula. Okay, so any right angle triangle, because all of these would be right angle triangles, this would be 90 degrees here, okay, which the sides of the triangle are known or they're not, right? It doesn't matter. But finding a side of a right triangle first arose in ancient Egypt, where people wanted to build things such as the pyramids. So we have certain geometric proportions that we needed to think about. So for example, if they were building a pyramid with a base of X and they wanted it to be so high, right? Then how steep would this slope be? What would the hypotenuse be? And that is what this is called. A line opposite of a right angle triangle is called a hypotenuse. So they needed to figure these things out in order to be able to build a structure that's going to fit properly and to know how much materials they needed. So there was a philosopher named Pythagorean, and this theorem was named after him because he figured this out. He was a traveler, and he figured this out. He was a Greek mathematician and philosopher, and now that this theorem actually holds his name. And so they came up with this formula, and I'm going to do it in a thicker one. It's a squared plus b squared equals c squared. And what that means is if I have a right angle triangle, and these are the legs of that triangle, okay? If I take this measurement here and I square it I guess I'll make that the base. That measurement there and square it, and this measurement here, leg A, leg B, and square it, I will figure out how long this is going to be. So, and this is called the hypotenuse. And that is the line that is across from, in a triangle, from the right angle. Okay? This is a word that you should probably remember, so make sure you write that down. Okay? Again, this is the right angle triangle here. This would be the base because it's the longer end. This would be the height here, and this is the hypotenuse. Okay? So, if you have a triangle here, and you're needing to plug the numbers into the formula, that's how it would go. All right, so I have my Pythagorean theorem here. If I'm looking at the x squared equals 25, and I'm trying to solve this problem, how does this relate to the Pythagorean theorem? Well, if I'm trying to solve for x, the opposite of squaring is going to be square rooting. So I would have to take the square root of both sides, which would cancel this out. And this would be this would be 5. Okay, and I can check this because if I squared 5 and then I square root it, right? 5 times 5 is 25, and then I square root it as 5. So it shows that this can be canceled out. Let's use this now. All right, looking at this first example right here. Okay, this is the hypotenuse. So that is the c squared because it's opposite of the right angle. Here is the base, so that's 5 squared, and here is the height, and that is 2 squared. So what do I have here? I have 4 plus 25 equals c squared. This is 29 equals c squared, and then I have to square both sides. So c is going to be equal to 29 squared, which is 5.385 centimeters. And that would be the length of this side. All right, do all of them except for this one and then come back. I didn't give you one side on purpose. All right, this one here, I have the base, which is 8 squared. I don't know what the height is because it's here. The right angle is opposite the hypotenuse, which is here, and that's 10 squared. It's really important that you remember that. If the right angle's here, that is the hypotenuse, and it goes here. Otherwise, you're going to get these wrong. All right, so this is 64. This is plus a squared. And then I have 100 here. I'm going to subtract 64. Okay, and then I'm going to end up with 36a squared. I'm going to have to write this off to the side. I'm going to square that, so a is equal to 36. All right, coming over here, I have, I don't know the hypotenuse, so that's c squared. I do know the height, that's 12 squared, plus 6 squared. So this would be 144 plus 36, that's c squared. So this would be 180 c squared, and then I'm going to take the square root of both sides, and that is going to be 13.416 centimeters. And the hypotenuse here is this length. Okay, now the reason I left this out is, what do I do now? So I have the right angle here. Obviously this is not that long, but I'm not going to make one that long. So I have the base here, which is 8 squared. I have no idea what the height is here. And c squared is the square root of 81 squared. All right, so this would be 64 a squared. And these would cancel each other out. So this would equal 81. So I have 64 minus, right? And then 81 minus 64 is going to be 17 a squared. And so I take the square root. What just happened? Yeah, sorry about that, guys. I could take the square root. I just touched a button. And this would be a equals, and then I take that square root, and it's 4.123 centimeters. And that's how long this side would be. Okay, so if this was a little bit too much, please make sure that you come to the help session.